Hello everyone, I am Jeevan Jospeh, a research scholar from Indian Institute of Technology, Bombay, working under the supervision of Professor D.N. Singh. I will be presenting on my research topic, gas migration studies on bentonite. This work was carried out at UPC Barcelona with Professor Enrique Romero as a part of European Union project GREAT. To give a brief introduction to my area of research, bentonite has been chosen as the liner material for nuclear waste repositories, landfills, etc. owing to its low permeability. However, their lifespan utility depends on the environmental condition they are subjected to. The deep repositories of nuclear waste liner are prone to gas pressures evolved from biogenic activities happening beneath the Earth's crust. This issue of gas migration should be taken care seriously, as the migration pathway in the liner system can result in atomic waste leaching into the geo-environment. The study was chosen keeping in mind these issues which might occur in a later stage of a waste containment system. The figure on the right shows the gas accumulation beneath a clay liner. As time progresses, more gas will be evolved, generating excess pore air pressure. This eventually leads to the formation of the pathways as shown in the figure. The simulation of such a mechanism on a laboratory scale requires incremental pressure application on test samples. The point at which the gas molecules find its way to come out of the system is indicated as the breakthrough pressure in the schematic graph. This is a photograph of the complete setup on which the gas migration study was simulated. As you can see, there are 4 fluid pressure volume controllers, an odometer cell inside which the test sample is kept, and an LVDT for measuring the axial deflection during the conduct of the experiment. The entire observations are continuously data logged inside the data acquisition system. A layer diagram is presented so as to have a clear understanding for the viewers. The sample dimensions adopted for the test was 50 mm in diameter and 20 mm high. The preparation of the sample prior to gas injection is described through this slide. Initially, the hygroscopic water content of the sample was determined, and it was found to be 7.2%. The water content of the sample was increased to 20% by water sprinkling method, and it was kept for 48 hours to equilibrate. The bentonite water mix is then compacted inside the mold to attain a density of 1.55 gram per centimeter cube. This was attained at a pressure corresponding to 6.5 megapascal. Later, the sample was saturated and it reaches the point D on the saturation line. The preliminary results of the experiment are described through this slide. The suction measured at initial condition and compacted state was found to be 92 megapascal and 21 megapascal respectively. It was also observed that the sample collapsed slightly while saturation. This might also result in slight increase in the density of the sample. The hydraulic conductivity of the sample was also measured by maintaining a hydraulic gradient at outlet and inlet. The permeability which was measured was found of the order of 10 to the power of minus 12 meters per second. The gas flow tests are also planned on the samples and keeping in mind the following steps. The gas injection should be carried out without removal of axial loading to avoid the uplift of the sample. Also, the minimum pressure to be applied for carrying out the flow of gas should be based on the dominant pore diameter, which can always be evaluated with the help of a mercury intrusion porosimeter. The maximum air pressure should be such that the lateral air pressure is greater than the injection pressure to avoid the flow of air at the sample mold interface. This work has to be continued and taken further to come up with solid conclusions related to gas permeability and gas migration mechanism. Thank you.